Hey everybody, at home at Old Guy Hi-Fi channel. Hope everyone's doing well today. Today should be an interesting video. Obviously, recently we've been discussing devices that have swappable op amps. I just did that Duke Audio A5 amp. We've done a bunch of DACs with swappable op amps. I've discussed different types of op amps. So what I thought today's video would be a little bit of a deep dive in what an op amp is and how it works and what purpose they serve in a variety of different circuit configurations. So, isn't that going to be exciting? Sit back, relax, get your slide rule out, and we're going to talk about techie stuff like op amps. So again, there's been a lot of discussion about op amps on YouTube and the internet and so forth and so on. And I kind of wanted to clear a few things up. And so everybody had a little bit of a better understanding of what an op amp does and what purpose it serves and what, maybe what's kind of like an op amp, but isn't necessarily an op amp, and maybe a bit on how they work. I apologize if this gets a little nerdy, but you guys know me, I'm a bit of a nerd. So let's talk about what an op amp and an amplifier circuit does. And I apologize, I've done a bunch of research on this, so I'm going to be reading from some notes so I get it correct. I don't want to upset anybody. So in an amplifier circuit, an op amp serves a bunch of different functions. It is voltage amplification. Now this is the primary function of most op amps in audio devices. It is designed to increase the amplitude of an audio signal. It takes a weak input signal and amplifies it to a higher voltage level. Op amps can also do signal conditioning. Op amps are used to filter, buffer, or modify audio signals before they're sent to other amplifier stages. This could include tone controls, equalization, and preamplification, which is obviously one that we're interested in as well. Op amps in an amplifier circuit can do impedance matching or buffering. An op amp can act as a buffer in a unity gain configuration, providing high input impedance and low output impedance. This prevents signal loss when interfacing with different circuit stages in the amplifier. They can provide active filtering. Used in active filters like low pass, high pass, or band pass filters, op amps help shape the frequency response of an audio amplifier. Feedback control, and this is a big one. Negative feedback using op amps stabilizes the gain of the amplifier, it reduces distortion, and improves linearity in amplifier circuits. However, too much negative feedback is not a good thing. Preamplification, and again, this is our most common application in hi-fi audio. An op amp is often used in a preamp stage to amplify very low-level signals, like signal coming from a turntable, moving magnet cartridge or whatever, or microphones, which are very low-level, very much like a phono cartridge. Sometimes just a standard 2-volt input, and that they amplify that signal before it goes to a power amplifier. So now let's talk about what op amps do in DACs. So we've been swapping a lot of op amps in DACs recently, and an op amp serves similar purposes, but kind of different purposes in a DAC than they do in an amplifier. So in a DAC, an op amp is very important in once the digital signal is converted, it smooths the analog waveform, obviously making a usable, good quality analog signal. So most commonly, op amps are used for current to voltage conversion, or I/V conversion. Many DACs, especially current output types like R-to-R ladder DACs or some delta sigma DACs, produce their output in the form of a varying current, varying with the frequency of the music. An op amp used in that current to voltage converter circuit transforms the current into a corresponding voltage that's moving up and down for further amplification and processing. They are used also for voltage buffering and impedance matching. An op amp provides low output impedance to ensure the DAC signal can drive subsequent audio stages, such as a preamp or power amplifier, and again, that's getting up to 2 volts or 4 volts depending, without distortion or signal degradation. They are used in signal filtering. Now, commonly they're used in what are called reconstruction filters. Since digital signals are inherently stepped, obviously you've seen the stepped waveform of a digital sample, right? And that's due to the discrete sampling. An op amp is used in an active low-pass filter, often called a reconstruction filter, to smooth out those high-frequency artifacts. Obviously, delta sigma DACs, some of them oversample up to 256 times, and there's a ton of switching noise, and one of the ways you can help get rid of that switching noise, there's other noise reduction circuits, is this reconstruction filter. So it helps smooth out the high frequency artifacts. That's called aliasing, and it creates a clean, or helps create a clean analog waveform. Op-amps are used for gain control and level shifting, and this is an important one. Op-amps can adjust the output voltage level of a DAC to match the required signal strength of the audio chain. So if you guys remember, I did a op-amp swap thing on a Duke Audio DAC Q11, and it has an ESS chip and an AKM chip. And I did a close-up, and I think I have a picture, and I'll put it here. On the ESS side, you can swap two op-amps. On the ESS side, however, there are two soldered op-amps directly to the board because that ESS chip puts out such low voltage that it needs to step up at least once through op-amps, left and right channel, to go into the next op-amps, which will then take that signal to the 2 volt needed for line out, because that only has single-ended out, where the AKM chip only needs to be stepped up once to get to 2 volts. So that's just one of the kind of an example of that. So they adjust that voltage. In some cases, they also provide some DC offset correction to remove unwanted DC components from the signal, which obviously can damage devices. Now, this is a big one, differential to single-ended conversion. We've seen a lot of DACs lately. A great example would be the Gishelli Daisy, which is a fully balanced configuration. It actually has 2 separate DAC circuits, 2 separate sets of DAC chips, and so forth. So in many high-performance DACs, the output is balanced differential signal. In an op-amp circuit with a differential amplifier, this converts, the op-amp converts that balanced to a single-ended signal, obviously for compatibility going on an RCA cable, because you've got an extra set of signals unbalanced. So the op-amp can do that conversion. So now let's talk about some various op-amp topologies. Well, before we look at different op-amp circuit topologies, I know you guys were waiting excitedly for that, I thought I'd break in and answer a question that someone in the comments had left me a day or two ago, and it just occurred to me. Do tubes and op-amps serve the same function in a similar circuit design? And the answer is, yeah, they kind of do, but they go about it in different ways. And another reason why I want to mention it is I'm doing a review of the Black Ice Audio CD Transport DAC, which has tubes in it. So we'll talk about that. So both tubes and op-amps can do the voltage amplification portion. Tubes do it. They provide voltage gain by controlling the flow of electrons between their various electrodes, the anode, the cathode, and the grid. Op-amps are always solid state. I'll put an X-ray of a 1656 op-amp here. On those little chips, in the traces there are resistors, capacitors, transistors, everything. Most op-amps are typically a bipolar or JFET transistor design, and that's what's used to amplify the signals. Both op-amps and tubes can do impedance matching and buffering. Tubes naturally have a high input impedance and a moderate output impedance. That makes them good for interfacing with high impedance sources. Now, op-amps can be configured, and they are configurable, to have extremely high input impedance and very low output impedance. That makes them more versatile for driving a variety of different loads. Both can do signal conditioning and tone character. Tubes, as we love it, add even order harmonics, that musical warm sounding distortion. They can also introduce a little bit of compression, bringing the transients down a smidge. And many of us find that to be a more pleasing overall sound, even though we may not be identifying that transient as being compressed just slightly, but it's the overall, that warmth that we get. Now, op-amps are designed specifically for linear, accurate, low distortion operation, and they're designed to provide very clean and neutral amplification. Now, both tubes and op-amps can be used to control feedback and linearity. Tubes typically rely on very minimal feedback, very minimal negative feedback, and that allows for more natural dynamics and kind of a softer, more organic sound to them. Op-amps use very strong negative feedback, which improves accuracy, stability, and distortion performance. However, too much negative feedback can be a bad thing and can add harshness. Now, both tubes and op-amps can be used for filtering or tone shaping. Typically, if you're going to see a tube in an EQ circuit, it's a passive EQ, where in active EQ circuits, you're going to find op-amps more often than not. So tubes and op-amps can do similar jobs, but they do it in a different way and with a different result. And one thing I want to mention is tubes typically have very high output impedance, where op-amps or transistors typically have very low output impedance. So if you've ever seen a tube amp, they always have big transformers on the back of them, because tubes are voltage devices, not current devices, and they don't like driving a low impedance load like an 8 ohm or 4 ohm speaker. So that's why there's transformers and taps to help kind of mitigate that oscillation or damage that the tubes would suffer connected directly to the speakers. Now there are amps, and I just did the LTA OTA Zodal Z40 integrated, which uses high-speed switching and a completely different output transformerless design. But basically most tube amps have transformers because of their very high output impedance. So now let's talk about circuit configurations for different op amps. Well, I know you've been waiting for this one. This is just exciting beyond belief. So what are the different circuit topologies used in solid-state op amps? Well, obviously it depends on their application. Now, op amps are used in all sorts of different circuits, not just audio circuits. They're used in measurement equipment, test equipment. They're used in, obviously, tons in telecommunication, because obviously you're amplifying human voice or data or whatever. So they're used for that. So some of the op amps I'm going to talk about, we don't see typically in audio applications, but it's kind of important to understand in how many different devices op amps are actually used. So one of the more common types, again, it's not necessarily an audio op amp, is called a voltage feedback op amp, or VFB. It uses high open loop gain with negative feedback. It has high input impedance, moderate to high gain, good linearity, low distortion. So that's one. Then current feedback op amps. Now, sometimes we'll see these in some audio devices on the pro side, compressors and limiters and things like that in the studio. That uses a current sensing feedback mechanism. It has a very high slew rate compared to the voltage feedback op amps. It has low phase shift and it improves stability in high speed applications there. And then there's one called a folded Cascode op amp. Now the Cascode, and this is a general term, Cascode is a circuit design, whether it's op amps or transistors or whatever. Cascode arrangement is a two-stage amplifier configuration that improves gain, bandwidth, and stability, and it has higher gain compared to a simple differential pair, which is what we're most used to. It has improved frequency response and very high output swing, the ability to swing lots of voltage. So they're used in high-speed and precision amplifiers, and again, not necessarily audio amplifiers, signal amplifiers of all sorts, IT, things like that. Then there's other ones, a current mirror op amp. This uses current mirrors for biasing and gain stages. It has good power efficiency. It's used in low power, high precision applications and widely found in modern CMOS op amps. Then there is what we're most familiar with, the Class AB output stage op amps. The output stage is designed to improve efficiency while reducing crossover distortion, again, Class AB. It balances efficiency and linearity, and it is the most common type in audio applications. And the one that is most common of all is the ubiquitous TI-NE 5532. We've seen these. These come in a lot of different devices that we get from, for the FunFi category. So we've talked about different op amps. Let's talk about how the different op amps, the specific op amps by model, work. Well, we've talked about the NE 5532, and I have this one on a DIP 8 socket. And again, I highly recommend you get some DIP 8 sockets. You can get them from Miles, or you can get them on Amazon. You can get them easy anywhere. This is an NE 5532, and there are actually two companies make them. TI makes them, and so does JRC, just so you're aware of that. They're both functionally the same. So what is some of the more popular op amps, the ones that we know really well? One of the most famous ones for us, anybody who owns a Gishelli DAC knows it, and that is the OPA 1656 from Texas Instruments. Now, this is configured to be on a stable DIP 8 socket. Normally, you'll see these soldered directly to a board, but these are obviously removable for swapping and very, very nice. So the OPA 1656 is a low noise, low distortion, JFET input operational amplifier designed specifically for audio and precision applications. And here's kind of its breakdown. It is a JFET input op amp. It uses a JFET based output stage for high impedance and low noise. It does have that voltage feedback portion. Again, the circuit on the integrated circuit are all discrete individual components, but they're all on a silicon die. So it does have a VFB topology that ensures good linearity and gain stability. It is Class AB output stage, again, reduces crossover distortion, making it suitable for audio. And it is a high performance audio op amp optimized for low distortion, low noise, and again, very popular choice for audio applications, whether amplifiers or DACs. Now, you'll find these things in all different kinds of stuff. You'll find them in some of the Class D amps that we have. Mostly you'll find 5532s in those, but you'll find these in DACs. You'll find them in analog to digital converters. You'll find them in mixing consoles, active crossovers, headphone amplifiers, measurement systems, any kind of precision instrumentation. It's a really, really popular device because it's very, very good and very accurate. So let's talk about the next one. So the next one is the infamous, or famous, obviously it is famous, Sparkos 3602, SX3602. And this is a fully discrete op amp. Rather than having all of the little resistors, capacitors, and transistors on a silicon die, they are all discretely mounted on a PC board. So they're more robust for sure, handle better voltage. And because of that separation, distance separation, there can be less interference between the various components. So fully discrete. Really important. And here's another important part. It is Class A bias, not AB. So it eliminates crossover distortion in the waveform. That's really important. It does have a voltage feedback portion. It provides high gain and excellent stability. And it is a bipolar input stage rather than JFET. Very low noise, very precise operation. So you'll find these in high-end audio preamplifiers and DAC stages like the Gishellis. You can roll those in. Also, too, Andrew Sparkos sells loads of these into the professional audio world for mixing consoles, mastering equipment, compressors, expanders, noise shaping, all EQs, all sorts of things. Phono preamps, recording interfaces. That's one big part of his business. Is not just op amps for DACs. So really high-end, very highly regarded. The 3602 is a go-to for me for sure, and I think a go-to for a lot of us. So now let's talk about the next one. Well, the next op amp is one I think that I introduced to the community. It is the PCS SX52B fully discrete op amp. Now, it is very much like a 3602. However, I don't believe it is a Class A bias. I believe it's a Class AB, but it is fully discrete using individual components and so forth. And obviously it's designed like the rest of these as a direct drop in for an 8-pin, DIP 8 socket. Now, one word of warning, and I like these, and they're very inexpensive. I think they're 12, 14 bucks, whatever. The one word of warning, and that is power consumption. The 3602s, the SX52Bs, any of these big, discrete, crazy op amps draw more power than, let's say, a 1656. So you have to be careful of that. And let me share an anecdote with you. On my Gishelli J2S, it's socketed, I had a 2590 running on single-ended. I also had, at one point, two 3602s or two SX52Bs running on the balance side, and the op amp got noticeably warm to the touch. And I think they were drawing more power. The discrete op amps draw much more power. So what I did was, because I don't use the balance on the J2S that frequently because it sits on my desktop more often than not, I took those out, put the 1656s back in. I left the 2590 in there, and things seemed to settle down a lot more. Still ran a little bit warm. So I threw the 3602 on the single-ended side, and it still sounds wonderful. We'll talk about that in a second. And then the DAC just ran cool to the touch. There was no issue whatsoever. So that's kind of the way I've got it configured. So again, you got to consider power consumption with these big solid-state op amp chips. So anyway, so what's the next op amp I want to talk about? Well, the next one I want to talk about, I actually don't have any examples here, and that is the Burson V7 family of op amps, the Vivid and the Classic. Now, I've had a little experience with them, but fortunately, Burson reached out to me recently and asked if I wanted some for review and for testing, and I said yes. So they're going to be sending me some op amps, a set of Vivids and a set of Classics, the dual op amps. And then I think I'm going to be getting 8 of the Vivid Classic single op amps for use in the Gishelli Daisy. They may be duals, I don't know. But anyway, they're nice enough to send them to me, so I'll have to report back later. But the Burson V7 is a fully discrete op amp like the Sparkos and like the PCS unit. It is designed to be very thermally efficient, very audibly clean and crisp because, again, all of the different, the separate component. It is a Class A biased op amp, not Class AB. And it has a real neat thing. They make a big deal of it, but I think other op amps have it, called reverse voltage protection. So we've talked about op amps having this little notch on the socket, and it lines up with a little notch on the socket on the board. And you don't want to put them in backwards. So the reverse voltage protection would protect the op amp against that reverse voltage. Now, how would I know this? Your host, author, and narrator is a ham-fisted buffoon sometimes. I put op amps in backwards. I put them in backwards, 3602s, backwards in my J2S. Couldn't get any sound out of it. Couldn't figure out why. I'm in a hurry, not paying any attention like normal. And then I went over and I smelled something and I turned it off really, really quick. If you've ever smelled electronics burning, you know that acrid disaster smell. It smells like, probably the 7th level of Dante's Inferno. So I pulled the op amp out, I powered everything down, I let it cool down, I took a new 3602, put it in, and lo and behold, the angels were smiling on me that the DAC worked fine. Now, a little bit later, I had the bad op amp, or what I thought was a bad op amp, mixed in with some other op amps. I plugged it in a DAC, and it worked just fine. So I think the Gishelli might have some reverse voltage protection, as does the Sparco's op amps, but it's a good thing, and Burson makes a point of it. It's great that they do, because if you're a ham-fisted monkey like me, you need that, right? So the Burson V7s come in 2 flavors. They come in the Vivid flavor, and they come in the Classic. Now, the Vivid is a more transparent, more dynamic, more, clarity is its focus kind of an op amp for someone who wants real precise sound. And the Classic is kind of a warmer, more lush, more mid-range focused, more vocal focused sound to it. So I'm going to have both, and I will give them both a try. Obviously, Burson op amps are really good, very high construction value, build quality and everything else, really, really nice. So again, they're another fully high performance, fully discrete op amp, Class A biased. So now let's talk about how I've used these op amps and in what devices I feel that what op amps work best. Well, I've been doing a lot of reviews lately with amps and DACs that have swappable op amps. That seems to be obviously one of the newer features a lot of these devices have, and I think it's a pretty good idea. It certainly makes it easier for us to tailor the sound the way we want it to. But I have noticed that certain op amps perform better in certain types of devices, and let's talk about that a little bit. So let's talk about the NE5532, which is kind of the stock op amp we find in almost every one of these devices, whether it's an amp or a DAC. It is a very good kind of Swiss Army knife generalist, general purpose op amp. They perform well, and devices can sound quite good with them in it. There's nothing wrong with it. They're very affordable. They're very easy to design circuits around. They're not very demanding of current and so forth. So again, it's a great choice for an OE application. Well, the next one is, and this is a very popular one, is the OPA 1656. These are a very good general purpose op amp. I think they might do slightly better in DACs than they do in amps, but it's very close. I do like them a lot in both devices, in both circuits. Now, for kind of the standard normal kind of op amp chip, I'm a big fan of the the NOS Burr Brown 2134 op amps in an amplifier. They sound really good. They add some warmth and detail. Very, very nice. Second choice would be the NOS Burr Brown 2604s. They're very nice. Third choice would be the TI, and it's either an OPA 826 or 628. I'll fix it down here if I can find out what it is. This one is good. This is new to me too. I've just started messing with it, but they're okay in the amplifiers. So most of these styles, especially the 2134s, I think do really, really well in an amplifier stage. That's what I'm running in that little Duke A5 I just recently did, which has replaced my IEMA A07 up on my editing desktop upstairs. That thing sounds wonderful with those in it. So anyway, that's that. Now, as we move up into the 3602s and the SX52Bs, the SX52B is a bit of a generalist. I think it can work well in an amp circuit as well, and I think it works quite well in a DAC circuit. The thing I like about these particular, the SX52Bs, is value for money. I mean, 12, 14 bucks a piece. They do a very, very good job. Are they as good as the 3602s? No, but we're splitting hairs. And for the cost of one of these, I could probably buy 4 or 5 of these. So it becomes a value. Now, would I put this in my Gishelli Daisy, or would I put it in a high-end expensive DAC? Probably not. Would I put this? I'd put this in any DAC. These are that good. Very, very good. But these, again, value. For the inexpensive kind of fun-fi DACs like the Duke Audio or some of the entry-level SMSL or that Neo Hippo I did, these work quite well. I really like them. The Fozzy DACs, this is a good choice. And it works quite well in their amplifiers as well. So the 3602s, I think, is obviously, we're talking about a fully biased Class A. So as far as performance goes, there's going to be different sonic signatures. What I remember my experience with the Burson V7 Vivids, because I had those in the J2S for a while, is that the 3602s and the Bursons are similar in that they're very high performance and very good, quite good. So they're, I think, best in honestly, in DAC circuits where that signal is really, really important to get it to the right level and treated right and get to the output stage so that it can get onto the amplifier. So again, I think 3602s and the Burson V7, whether the classics or the Vivids, I think are going to be your best choice there. We've got some other ones I've got to try. There's a company called Muse that makes op amps. I've got these, which are giant. You can see how huge they are. Looking at these, and just it's a gut feeling. I think these are going to be better in an amplifier stage, and probably an amplifier board or style is going to be the only thing that's going to be big enough to fit these. So we'll try those, report back on them. Now, obviously the Mac Daddy, the 2590s, this is absolutely stellar in the output stage of a DAC. I have not tried them in any amp yet because I don't have an amp where this thing fits. And I'm not going to stack dip 8 sockets, you know, to get it 3 inches above the board so everything fits. But in a DAC, in the single-ended end of a J3 Pro or a J2S, wonderful stuff, really good. And this is what's called a dual dip 8 fully assembled SS2509, because there's actually 2 chips there. You can see the 2 boards, and they're put together in a single 8-pin. Now in the Daisy, you just need 8 of the single ones. And again, you have to replace all 8 in the Daisy. I have them in the Daisy, and I'll tell you what, with this op amp in the Daisy and the linear power supply, it outperforms that Pontus 12H that I reviewed. So we'll leave that one hanging in the air there. So anyway, I hope you enjoyed a little bit of a discussion about op amps so we can get a better understanding of what they are, how they work, and why they're important, and why it's a ton of fun to swap these things. And it doesn't have to be expensive, and it doesn't have to be intimidating. I hope it isn't. Well, anyway, hopefully you enjoyed the video. Hopefully you're willing to give me a like and your subscription. Many of you who are watching the video don't subscribe, and it would really help the channel out if you did. More manufacturers would be willing to send me more cool stuff to review, and obviously we can have some fun with that together. If you wish to support the channel, there is a thank you button at the bottom of the video window if you're watching on your portable device or on your computer. There is a membership link in the pinned comment and in the video description. I will list all my op amps in the video description. If I can find links for things, I will. If it's an AliExpress link, I have no affiliation. There may be an occasional Amazon affiliate link in there for op amps. You know how that works. In the video description are also other Amazon affiliate links, and I'm going to pare that down a little bit. It's getting kind of long. And I'm not in to try to sell stuff. I just wanted to give you guys easy access to things. There are also some playlists, a community post playlist. Comment, let me know. What do you think about op amp swapping? Have you done op amp swapping? Have you found an op amp you thought worked really good in an amplifier circuit or in a DAC circuit? Or are you curious about what would this op amp do in this particular circuit topology, amp or DAC or whatever? So let's start some discussion about that. I also really appreciate it when you guys help each other out in the comments. I'd also really appreciate it if we kept the comments concise and short. I appreciate everybody wanting to share, but when I get a 7 paragraph long comment, I'll be honest with you, I'm not that motivated to look at it because I get so many comments and I try to read every one of them and I try to respond to as many of them as I can. But when I get a Moby Dick length comment, I'm sorry, I'll just breeze through it. And if there's something real quick I can answer, I will. Also, too, if you're going to ask me questions, keep in mind, keep the questions short, succinct, and be as specific as you possibly can. Because sometimes if I don't have an answer, but I think I can find the answer, I'll go do research, find an answer, and I'll give you back that answer. Also, too, if you're asking me advice about products, if I've reviewed the product, I will offer advice. If I haven't reviewed the product, I'm not going to bullshit you and make something up. So look back at my videos, look back in the playlist. They're all organized by DAC and amp and speakers. If you've seen me review it, ask the question. If you haven't, I'm sorry, I'm not going to be able to help you out very much. Anyway, that's that. Please like, subscribe, comment. You can follow me on Instagram if you want to. My name is Ed Homewood. This is the Old Guy Op Amp Swapping Channel. And hopefully you enjoy that. Hopefully you can sit back, relax, and contemplate your next op amp swap. What will it be? A DAC, an amp, a 3602, an SX52B? Much to ponder. Thanks so much for your time. I really appreciate it. Have a wonderful day.